So right now I can see there are no VPCs in my network. I can see the region is North Virginia. So they've given us this default region, right? Which is in US, North Virginia. Do you see any current VPCs? The number is 0. That means we do not have any default VPC which is created. We do not see any subnets. That will be again 0. Your routing table will be 0. But there will be an default internet gateway. So if you go to the internet gateway, I think this one is also the one which I created. So I'm going to go ahead and delete this internet gateway. So there is no internet gateway as well, right? So you can see one DHCP option set, which is there. We're going to keep it as it is. We're not going to touch that. So now what we're going to do, we're going to click on VPCs, and then we're going to create a VPC. Right? Now we're going to give it a name. So what are we going to name it? We're going to name it Custom Lab VPC. That's the name which we have specified in the lab guide. You can use any name that you like, but for the sake of consistency, we're going to use the same name. So Custom Lab VPC is the name that I've given. And then I have to specify the network in which I'm going to create my subnets. So we have decided that we will use 10.0.0.0/16 as our network block. That is also called as a CIDR, CIDR block. So in your home page, you can see it's asking for IPv4 CIDR block. That is the range of IPs that we're going to create a network from. Now, what does that /16 indicate? We already talked about this. What is that /16?
Identifier, sir.
Network identifier,
Hmm.
right? So when I'm doing 16, that means the first 2 blocks. Each block contains 8 bits. So I'm reserving first 2 blocks, that is 16 bits for my network. So my network is going to be 10.0. Within that 10.0, I'm going to create further subnets. Now, how many IPs can we create from this block? That is 2 remaining subnets, 0.0, right? So 255 for each first octet, and again 255 for the second octet. So total I can create 65,000 combinations, unique combinations of those 2 blocks, right? So I can create 65,000 something IPs from this network. Okay. If I'm reserving first 3 blocks, then how many IPs can I create? 256, right? So right now we have specified that first 2 blocks are going to be my network. That is why I've created /16. So I'm going to specify a range called 10.0.0.0. So my network address is 10.0, first 2 blocks. We're going to keep IPv6 to default. We're not going to create any IPv6 CIDR block. We're going to keep the tenancy to default. We're not going to change any option. Then it will automatically create a tag called name, right? And the value of that tag will be the name you provide to the VPC, that is custom lab VPC, right? So all we have done so far is we specified the network and the size of that network in which we're going to create our resources. And we have specified the name for that VPC called custom lab VPC. So you're going to create VPC. It will take a minute, few seconds, and it will open up the home page for that VPC. It will have some unique identifier, that is VPC hyphen something, and then it will show you the custom lab VPC. That is the name that we have set. So that is our first step. Now what we need to do, let's go back to our lab guide, and we need to create an internet gateway. To provide internet access, I'm going to create a internet gateway. And we're going to name it custom lab IGW, that is internet gateway. So we're going to follow the same naming convention, that is custom lab, right? So we created custom lab VPC. Now we're going to create custom lab IGW, that is our internet gateway. How do we do that? In the virtual private cloud section, that is on the left hand side, you see your network components, your VPCs, subnets, routing table, and under routing table, you have internet gateways. So you're going to go to the internet gateways, and on the right hand side, you see the option create internet gateway. I'm going to go ahead and click that option, and I'm going to provide the name, that is custom lab IGW, and the name tag will automatically get added. And I'm going to create internet gateway. So now we have created our virtual network, as well as we have created an internet gateway. Now the next step we're going to follow is create two subnets, right? One is going to be our public subnet. So the name is public subnet. And the IP range that we're going to provide is 10.0.1.0. So this IP range has to be within the same range that we have given for the VPC. It is a subset of that. So out of 65,000 network combinations or IPs that I can create, I'm going to create one subnet, and I'm going to specify the network ID as 10.0.1. Hence, I'm specifying the network identifier as /24. So we're going to go back to our AWS console. We're going to click on subnets. So we're going to create first subnet. So we'll name, first you have to select under which VPC are you going to create that network. So you have to specify our custom lab VPC that we created. It is showing me that it has to be within this range. And then I can specify subnet settings. So I'm going to create my first subnet, that is public subnet. And now I can see the availability zone in which we can create this subnet. So in this AWS console, I can only see one region, that is North Virginia. And in that region, I have three different availability zones. So I can see there is US East 1A. Then there is another availability zone called as US East 1B. And then there is third option, 1C. And again, there is also fourth option, 1D, and fifth option, 1E and F. So in North Virginia, I am able to see almost 6 availability zones. These are separate data centers with each having its own power supply, network connectivity, and cooling devices, right? So we can select any of these availability zones. I'm going to select the first one, that is 1A. And then I have to specify the IPv4 subnet CIDR block. So that has to be within my VPC CIDR block. That's why I can see this 10.0.0.0/16. So the name, the IP range we're going to create is 10.0.1.0/24. That means my first 3 octets are my network, that is 10.0.1, and the remaining octet is my host identifier. So you can see on the right hand side, it is showing me how many IPs can I create in that subnet. It's saying 256 IPs. If I say 16, it will show me how many IPs I can hold there. 65,536 IPs. That is my entire VPC's range, right? So I'm not going to use the entire range. I'm going to use only one subnet, that is called 10.0.1, right? So my CIDR block is going to be 10.0.1.0/24. Everyone is understanding what we are creating? If you have any doubts what we are doing, just let me know. And in the same page, I can add another subnet. So I can create 2 subnets at a time. I'm gonna name this subnet as my private subnet. Availability zone, I'm gonna select the same zone, US East 1A. And then I'm gonna specify the CIDR block as 10.0.2. So the block address will be 10.0.2.0/24. I can see the tags are automatically added. And I've specified both the networks, that is my public subnet and private subnet. So I'm going to click create subnet, and it's going to create 2 subnets for me. One is called private subnet, one is called public subnet. And they have their unique identifier, that is subnet hyphen and some unique code. And I can see they are both attached or created in my same VPC and the respective network range for each subnet. So we created our VPC, we created our internet gateway, we have created now subnets. So what is the next step? I'm going to have to create a routing table to facilitate traffic between these subnets. So now we're going to go and create a routing table. So I'm going to first name my routing table public RT. That is my routing table for public subnet. So on the left hand side, you see the option route tables under subnets. We're going to create route table. We're going to provide the name, that is public RT. We're going to specify the VPC. So everything, every resource that we are creating under the VPC. That is our virtual data center. I'm going to provide the name tag as it is. I'm going to create routing table. Now this is my public routing table, right? So what I need to do, I need to provide it internet access, right? How do I provide it internet access? I need to create a route. So I'm gonna go ahead and select add route. So you have on the right hand side, you have seen edit routes option. Once you click on edit route, you're going to click add route. And under the first section, you see default ranges, right? What we can create. So we're going to select first option, that is 0.0.0.0/0. What does that mean? That I can forward any traffic outside this network to my internet. So any host or remote machine who has internet access, right? I'm going to provide this internet access to this subnet or the route. So I'm going to select 0.0.0.0/0. That is every machine in the internet. And my target will be the internet gateway. So my next hop on this routing table, that is my router, the next hop is going to be on internet. So I need to specify my internet gateway here. So let's see what name did we give to our internet gateway. Custom lab IGW. So we need to name it starting with IGW hyphen, right? So I'm going to go back to my VPC and go back to my internet gateway. And I'm going to change the name. So I created the internet gateway, but I did not attach it to my VPC. So I missed that step, right? It should be there in the lab guide. So when we created that gateway, we need to select attach to VPC and add it to our custom VPC that we created. So I'm going to perform that step and click attach gateway. Now that my gateway is attached, let's go back to the routing table. I'm going to click on edit rules. I'm going to click on add rule, add route, select 0.0.0.0/0. I'm going to select internet gateway. And now I can see the custom lab IGW. That is the gateway that we created, right? It is starting with IGW hyphen and the unique identifier. And in bracket, it's showing me the name that we gave, right? That is the custom lab IGW. I'm going to select that gateway. Yes.
Excuse me, sir.
Yeah.
Sir, can you repeat that step again to how to attach that?
Okay. Let me just save this. And we'll go back to the internet gateways, right? So you see the gateway that we created, custom lab IGW. We're going to click on the unique identifier, that we are going to go to the home page of that gateway, and under actions you see attach to VPC. So you're going to attach that gateway to the network that we created, that is the VPC that we created. All right.
Yes, sir.
So we created our VPC, we created our gateway, we attached it to the VPC. Then we created two subnets. Now we are at the routing table. So in the public RT, that is the public routing table, what I have done so far is I added an route for 0.0.0/0, that is internet, and I provided the target as my internet gateway that I created, right? Now I need to associate this routing table to one of the subnets. So which subnet I'm gonna associate this with to? My public subnet, right? So you're gonna go to subnet associations, and under subnet associations, you're gonna click on edit subnet associations. There I can see the two networks or two subnets that I created. I'm gonna select public subnet, since this is my public network which is exposed to the internet. I'm gonna select that network or subnet and click Save Associations. So in my public routing table, I have done two things. I went to the subnet associations and I associated that routing table to my public subnet. And under routes, I added a route for the internet connectivity. That finishes my public routing table. Now I also need to make sure my two subnets are able to talk to each other, right? Public and private subnets. So again, I'm gonna create another routing table. So I went to the routing tables and create route table. This I'm gonna name it as private RT. Yes.
Sir, can you please repeat what you did in subnet associations?
Okay. So let me show that to you again. So we went to the routing table, right? We clicked on the routing table. First, we need to add a route. How did you add a route? You click on edit routes and add a route. So we added the route for the 0000/0 and pointed the target as my internet gateway. So now you can see the status is active for both routes. You're gonna save changes. Then you went to subnet associations. You will click on edit subnet associations. We have to associate this routing table to one of the subnets. So since this is my public routing table, I'm gonna associate this with my public subnet. Similarly, I'm gonna create another routing table. So I'm gonna create another routing table, name it private RT. We're gonna select the VPC, that is the same VPC that we created. You're gonna create routing table. Once you have routing table created, now here, this is our private subnet. We do not want this subnet exposed to the internet. So we are not going to add a route in this routing table for the internet. We're gonna only associate this routing table with our internal private subnet. So I'm gonna again go to edit subnet associations and I'm gonna associate my private subnet here and click on save associations. All right. Everyone is done until this part. Yes, no.
Yes, sir.
Yes, sir.
All right. Now we need to create the firewall rules, right? So first we're gonna create a security group, that is the firewall rules, called SG public, right? So we'll go to the security groups. Under security on left hand side, you can see network ACLs and security groups. You're going to create a security group. I can see there is a default security group. We are not going to use that security group. We are going to create our own. So I'm going to name this security group SG public. And I'm going to give it a description that allow SSH from internet. Right? We're going to use SSH and we're going to allow any computer to connect to this machine from internet. So I'm going to select same VPC, that is my custom VPC. And I'm going to create a rule. So which rule I need to create? I need to create an inbound rule and allow any machine from internet to connect to this machine using port 22, that is SSH. So we're going to add rule under inbound rule. We're going to select type as SSH. So by default, when I selected SSH protocol, it automatically took the default port. That is the port 22 TCP. Right? And then source, we're going to allow all the machines from internet. That is anywhere using IPv4. Now in production environments, do we need to allow any machine to connect to our remote server or public server? No, right? If it's going to be a production server, except it is my public website. So I want everybody to be able to browse my public website. But for SSH connection, that is remote login to my server, I should not ideally use any IP from the internet, right? We will only have the specific IP range that will belong to my on-premises location or the organization. But since this is our lab scenario, we want to connect to this machine from our laptop, right? So for that, we're going to allow any IP that is on the internet. So how do we specify that? 0000/0 anywhere from the world. And that's why you see the warning that rules with source of 000 will allow all IP addresses to access your instance. We recommend security group rules to allow access from known IP addresses only. So in production environments, you want to specifically add the IP address or IP range from which you want to allow the access. So right now we have added 0000, that is any machine over the internet should be able to communicate with this server using SSH port 22. So go ahead and create security group. Then we're gonna create another security group called SG private. So you'll go to security groups. You'll create one more security group, which is called SG private. And I'll allow the description as, set the description as allow SSH only from internal subnet. That is my subnet created in the VPC. So we're gonna specify the VPC the same. I'm gonna add an inbound rule. I'm gonna select SSH And now instead of any IP, I'm gonna specify the subnet of my public subnet, that is 10.0.1/0/24. That is the CIDR block we created for our public subnet. Yes. So I'm not gonna allow only machines from that network range to be able to SSH into my internal server. I'm gonna add one more rule here, which I have not specified in the lab guide. So for our testing, that how are we going to confirm whether my public subnet server is able to access my private subnet network? I'm gonna add a rule all ICMP version 4. So what does that ICMP IPv4 mean? Anybody wants to guess? What is ICMP? Your ping command. When you ping a remote server or IP and you get a response, we are using the ICMP protocol when we are running ping. So by default, my firewall blocks the ping. So even if there is a remote access, I cannot get the output from ping command. So to allow that output, I'm going to allow all ICMP version 4, right? And I'm going to specify the same subnet range that we have created for public subnet. So once I've added these two inbound rules, I'm going to create that security group. All right, we created two security groups. In first security group, we allowed SSH access from all the machines in internet. And in second security group, we have allowed only servers from running in the 10.0.1 range to be able to SSH into my private server. And I've also added a rule to allow ping, that is my ICMP packets. All right, so we have created firewall rules as well. Now our skeleton network is ready. We have our parent network or virtual data center in 10.0 range. We have two subnets. We have associated an internet gateway and added that route for routing table in the public subnet. We also created a routing table for our private subnet. And then we created two firewall rules, that is two security groups, one for our public subnet and one for our private subnet. Now we are ready to create and launch EC2 instances, right? So first we're going to launch our EC2 instance in our public subnet. So I'm going to go to my home page. So if you click on AWS, it will bring you to your home page. In that, we're going to click EC2. That is our virtual machines. If you don't find this on your home page, you're going to also see EC2 in a search bar. There I can see several options: EC2 Global View, EC2 Image Builder, and EC2. I'm going to click on EC2. Now, when you go to the resources page or the dashboard for EC2, it shows you number of instances running, right? So I don't see any instances running. That is, instances running is 0. I can see auto scaling groups, which are also 0. Then I have instances 0, elastic IPs 0, dedicated hosts 0. I can see 3 security groups, 2 which I have created, and 1 is the default security group. So I'm going to go ahead and create an instance. So you say launch instance, click on launch instance. And let's see what are the options that we have. First, we need to provide it a name. So what is the name that we're going to use? We're going to use the name as jump host. That is going to be our public server, right? So that's the name I'm going to give. After you give the name, it asks us application and OS image. That is Amazon machine image. So there are several options which are there. Amazon Linux, Mac OS, Ubuntu, Windows, RHEL, SUSE Linux, Debian Linux, and so on. If you click on browse more API AMIs, it will take you to the marketplace, right? Where all the companies and different application softwares, they have created their own images, right? So for our lab practice, we're going to use the Ubuntu image. So we're going to click on Ubuntu. And then under Amazon machine image, we can see several options. So there is a first option, Ubuntu Server 24.4 LTS SSD volume type. And there are also some other images, right? Standard, volume type, PyTorch, TensorFlow, etc. So rest of them are the paid configurations. We're going to use the basic configuration, that is our free tier available. So you're going to select the same first option, that is free tier eligible. Then it is telling me that it is a 64-bit architecture. When was that image published? It was published on 21st August 2025. So it is the most recent version of Ubuntu, right? That image was published just a week ago. Now we want to select the instance type, that is the configuration or hardware we're going to associate. So you can see multiple combinations there. So the smallest one is T2.nano. What is that configuration? It is one virtual CPU and only 500 MB of RAM, that is 0.5 GB memory, and some other settings. Then you have T2 micro, that is one virtual CPU and 1 GB memory. It says free tier eligible, but when you run that virtual machine, there is some additional pricing that we need to pay. So it gives you the pricing on demand Windows based pricing $0.0162 per hour. Ubuntu Pro base image $0.0134 per hour, etc. So we're gonna keep the same instance type as T2 micro, which is free tier eligible. And then we create the key pair. So you can either do that in advance, or if we have not done that, we can create a key pair now. So you're gonna select create new key pair. Now I had already created one key pair called Ajit. So I'm gonna use that, right? You will provide a name for your key pair and you're gonna click create new key pair. Once you do that, it will download a .pem file. So if you select on this, right, you have to proceed the name, then you need to provide the key pair type. So key pair type we're gonna use is RSA, and the private key file format we'll select as .pem. right? And for PPK, that is, we can use it with putty, right? So right now we're gonna not use putty, but the SSH client that we downloaded. So we're gonna use the same open SSH format, that is .pem file. When you click on create, it's gonna download that PM file on your machine. So you need to save it in a proper location. Let me find that key file on my machine where I have saved it. So let me see. Okay, this is the file. I'm gonna put this in my D:CDC training prompt. Let me share my screen again.
So
No, that is not an issue. So whatever availability zone or region you're getting in your list, you can keep that. Just make sure the availability zone is for the same for all the two subnets, right? We're gonna use it in the same subnet, in the same availability. So for both subnets, we're gonna use the same availability zone, right? We can also select different availability zone to create high availability, right? But then we are gonna use two more subnets for each availability zone. Right now, we are not implementing redundancy and fault tolerance. So we are going to create only one subnet and one availability zone. So use the same availability zone for both. Okay. So everyone is at this point. We have created a new key pair. Store that key pair in a location where you can easily access, let's say D drive. Okay, now I have to specify the network that I've designed and apply that network for this virtual machine. So I'm gonna not accept. By default, it is showing me custom lab VPC, but the subnet is wrong. It's showing private subnet, right? I'm creating a server in public subnet. So I'm gonna click on edit and I'm gonna select my public subnet here. And public subnet or a public server, I'm gonna select auto assign public IP. So for that, you need to click enable. This step is important because it will give you a public IP which you can access. By default, is 10.0.1 IP. Again, that is in the internal range. We cannot access that from external network, from internet. So we need a public IP for this. We're gonna enable public IP, and then we're gonna select our existing security group. So if you select, you can see the public security group that we created, which allows SSH access. So we're gonna select that SG public group. Then there are some settings which are under advanced network configuration. We're not gonna change those. We're gonna keep it as it is. And then we need to configure the storage that is required for that virtual machine. So by default, it tells me that free tier eligible customers can get up to 30 GB of EBS, that is elastic block storage. That is the local storage that this virtual machine is going to use. General purpose, and that storage will be on SSD or magnetic storage. So instead of 30 GB, I'm going to keep it same, that is default 8 GB. Right? And on GP3, I can see the storage layers that I can select. What are those storage layers? General purpose SSD, that is GP3, then general purpose SSD, that is GP2, then provisioned IOPS SSD, that is IO1. So if you just select is the root volume non-encrypted, my IO1 is 400 IOPS per second and non-encrypted. IO2 is 8000 IOPS non-encrypted. So I'm going to use this default setting, that is general purpose SSD, which is giving me 3000 IOPS and not encrypted. I'm going to keep it as it is. So we're going to GP3. I'm going to keep 8 GB as my local storage. I'm not going to add any new volumes. And I'm going to keep the advanced details to default. I'm not going to change any advanced details. So what have we specified? We have specified that is jump host. We have specified the Amazon machine image, that is Ubuntu server in our free tier. We have selected the instance types as T2 micro, which is also free tier. We created our own key pair and we have stored it. We have edited the settings, network settings. We associated with our VPC and our public subnet. We have auto enabled the public IP and we selected our SG public firewall, that is the security group that we created. Rest everything we're gonna keep default and we're gonna click on launch instance. It's gonna take a few seconds and it will give you a display that you have successfully initiated the launch of instance. And then it gives me the instance ID. If you click on that, I can see the details about my instance, right? You can see instance ID, which starts with I. Then I can see two IP addresses. One is my private IP address, that is 10.0.1 range that we specified, and it gave me an IP.115. So you can notice this is the IP range that we have specified on our public subnet, right? That is 10.0.1. And we got the IP address .115. And we also have an public IP address. So in my case, it is 34.207.218.44. That is my public IP and my instance is running. So I'm gonna keep this as it is because we're gonna need one more instance to create in our private subnet. So I'm gonna again go back to instances. I can already see my jump host instance is running. I'm gonna click on launch instance. And now I'm going to create one more instance, that is my private instance. So what are the settings that we're gonna name? We're gonna name it as a private host. So let me copy paste that name. I'm gonna give the name as private host. I'm gonna keep the same settings, that Ubuntu server that we selected for our public host or jump host. I'm gonna select the free tier available image 24.04. Instance type, again, I'm gonna click the same, that is free tier eligible, that is 1 CPU and 1 GB RAM. Now I don't need to create a new key pair. I'm the same key that we created earlier, right? Because that's the key we have downloaded. So instead of creating a new key pair, we're gonna select the existing key that we created. Now, what are the network settings? I'm gonna click on edit. I can see that it has taken custom lab VPC already in the private subnet. auto assign IP, I'm gonna disable, right? I don't want this machine to have a public IP address. But I'm gonna click on existing security group and select my private security group. That security group allows me SSH access from my public network. Also, it shows me ICMP protocol, right? So that is also enabled. I'm gonna keep the storage to 8 GB and GP3, which is default. Rest all the settings we're gonna keep default and click on launch instances. And it has created another instance, which is our private host. Okay, so now if you go back to instances, you can see there are two instances running. One is my private host and one is my jump host. Let's go ahead and click on jump host, right? We're gonna access that jump host. So how do we access this? First, we will copy the public IP address. So there is a copy icon. If you click on that, it copies your public IP address. And then when you click on connect, it gives me connection types. Either I can connect using another EC2 instance, that is EC2 instance connect, or a session manager, or a SSH client. So we're gonna use SSH client. What does it tell us? It says open an SSH client, locate your private key file. That is the file that is saved. So it is telling which file that we created. The key used to launch this instance is ajit.pm, or the private key that I had created. Now, if you're going to use this private key file from a machine which already has SSH capability, like for example, your Mac OS or your Linux, right? You have to modify the permissions of that key file to chmod 400. That means read only. By default, when you download that key file, it has read write access, right? So you want to change the permissions to only read. So right now we're going to use SSH client on our Windows system. So I don't need to change any permissions for this key. And then what is the procedure? I gonna connect to my public IP, and the command looks like this: SSH-I. Then in quotes, I'm gonna use the key file or the path to my key file. And the default username for that Ubuntu image is Ubuntu, right? That is the user ID which is created by default. So we're gonna select Ubuntu, that is the username, at the public IP of my instance, that is 34.207.218.44. Now, since I'm not gonna use command line to connect to this SSH, right, instance, not need to issue this command. Instead of that, I'm gonna open up my SSH client. So now you need to go ahead and download that SSH client. So I have this client here. I'm gonna open this client. So if you have not downloaded this, go ahead and download that client. And let me know when we are good to see. That is, connect to that is our SSH client.
Sir, which edition we have to download? Home edition.
Yes, that is for personal use, right? So we're gonna use home edition.
Or installer edition, right?
So you can use installer. If you're downloading installer, then you have to install it, right? or you can also download the portable edition. That is only the folder you need to unzip, and then you can directly use that. So I'm using portable version, so I don't have to install it on my system as such. I can directly go to that folder and then click on the exe to run that SSH client. So you can download any version, either portable or installer. If you are downloading installer, then you have to make sure that you install that and open the client. All right, everybody has downloaded the SSH client?
No, sir.
Okay. Just make sure you don't delete any existing resource which is there, right? By default, we are creating our own resources. We are creating our own VPC. We have created our own subnet, our own routing table and a gateway, and we are using that. Meanwhile, my session is expired. I'm gonna click on the refresh, connect.
Sir,
So you will keep the key pair type as RSA, and you will export a .pem file, not a PPK.
Excuse me, sir.
Yes.
Sir, can we have a lunch break?
So can we just finish this quickly and then we can terminate the resources because we don't want to leave this running for an hour, right? Since we have already created those instances, those are chargeable. So we don't want to ruin out of your quota, that is $5 quota. So let's finish this exercise. Not much remaining. We have already created 2 instances, right? We just verify the connectivity and then we can take a lunch. All right, everybody created a key pair and downloaded the SSH client.
Yes, sir.
All right, so I'm gonna open up my SSH client. Are you guys still able to see my screen?
Yes, sir.
All right,
Yes,
so you're gonna click on session, right? On the left hand side, you see start a new remote session. We're gonna click on the remote session. Under that, we're gonna create SSH, right? So we're gonna select session type as SSH. Now we're gonna copy paste the public IP. Like I'm gonna copy this public IP and paste that as my remote host. Right? I'm not gonna specify any username right now. I'm gonna click on advanced SSH settings. I can see that it is configured on port 22, so that is okay. So under advanced SSH settings, we're gonna select use private key. So select that option, use private key, and then you have to point it towards the path where you have saved the PEM file. So ajit.pem, that is the private key file I've downloaded. I'm going to use that ajit.pem, right? And then I'm going to click OK. So it's going to show me a warning that this is first time you're connecting to this server. I'm going to say accept. I trust this identity. Now it's going to ask me the username. Login as. So what is the login name that we selected? Ubuntu. That is the default username. So I'm gonna enter Ubuntu. It is automatically with the private key file that we imported. So it's not gonna ask us any password. And I'm directly logged in into my remote server. I can see Ubuntu @ IP-10.0.1.115. That is which I'm logged in into. That is the jump host, right? I can see top command, what are the resource consumptions, right? I can see ifconfig. So ifconfig is not installed in Ubuntu image. Then what else we can check? Now we want to check, are we able to connect to our private server from this machine, right? This is our jump server. We want to be able to connect to our private network, which is not exposed to the internet. So what is the IP we received for that private server? I'm gonna again go back to instances. I'm gonna select my private host, and the IP which I received is 10.02.17. That is my private subnet 10.02, and the IP I've 10.02.17. So I'm going to select ping and paste the IP address of my private server. And I'm getting a response. That means I'm able to successfully connect to my private, that my private routing table is successfully created. You can see that it is using ICMP. So you can see I sequence 1, 2, 3, 4, 5, 6, 7, right? And why we are able to ping it? Because we enabled that ICMP protocol in our firewall. Otherwise, you will not have any response from this host, even if it is connected, right? All right, now we want to see whether we can SSH into that private server. SSH, the IP address 10.0.2.17. It is giving me some default key, right? This key is not known by any other names. Are you sure you want to continue? I'm going to say yes. And it gives me an error message, permission denied. Because whatever public key is being used, we have not imported our private key into this machine. Remember, when we created that private server, we associated that with the same private key that we downloaded. So now what I have to do, I have to import this private key into this machine, right? So either I can use the SSH client and transfer the file, or I can copy paste the contents, right? So I'm going to create a new file called vi. Let me see first which directory I am under. pwd. So I'm under the home folder of Ubuntu user. Okay. I'm going to create a file vi ajit.pem. That's the same file which I downloaded. And it opens a blank vi editor. Now what I need to do, I need to go back to the location where I've saved that private key, and I have to open that private key in the notepad. So you can see that content of the private into the notepad. We're gonna select entire private key and we are gonna copy it. Now, since this is a SSH client, I can use copy paste, right? So in this vi editor, I'm gonna select I for insert, and I will paste that key. If you right click, it will paste the entire content. So I'm copy pasting this key. I'm gonna save it, escape wq hyphen. That is, right now we have added that private key. Well, let me see the content. So I'm gonna cat this and I can see that the content are properly saved. Now there is one more change I need to do. What is that change? I need to change the permissions of the key file. Since this is a Linux machine, it can directly SSH, right? It does not need a SSH client. So we're gonna change the permissions. We're gonna use chmod 400, that is read only, and the file name. So now I have changed the permissions of the key file. I can use it to directly SSH into my remote client. And what is the command that we need to follow? Now we will use the command which is given by our Amazon, that is SSH-I. We're gonna specify the key g.pem, and we will specify the username Ubuntu @ the private IP of my private server, that is 10.0.2.17. I'm gonna hit enter. And without any password, it's gonna directly log into me into my private server. You can see the IP is now changed, 10.0.2.17. I'm gonna select the uname. The username, the host name is Linux. So that means my jump host, that is my public server, can successfully access my private server, even though it is not exposed to the. I'm gonna click exit. I will again come back to my original server, that is my public server, 10.0.1.115. I'm gonna exit that session as well, and it will terminate the session with that SSH client. We have successfully verified that we can remotely access our public server, and we have also verified that we can access the private server by using SSH public server. That means our lab is successful. So once you have verified this, all is we need to destroy all the running instances, right? Because it is charging us by second. I'm gonna select instance, and under instance tastes, I'm gonna select terminate instance, that is delete the instances. We can press stop instance, but that will only shut down the instance, right? We want to delete that, because even though my instance is not running, it had created that 8 GB disk. So even though the instance is shut down, that is stopped, we are still getting charged for the storage, right? So that's why we need to delete the instance. So it's gonna delete automatically the local storage as well, so that now I don't need to pay charges. I can see that successfully all the instances have been deleted.
Sir, after the copying that data in the PEM,
Yeah.
how to save that file in the Ubuntu?
So once you do a VI and specify the file, right? If
Inside
you
the data, sir.
editor, you need to press I to be able to enter data. You press,
Data.
then you right click and it will paste the data. Now you have to save it. So again, you will do escape :WQ and exclamation mark. That is, we are saving the file. We already talked these commands and VI utility when we saw our Linux labs. Once you save, you'll just confirm that it is properly saved. So you're gonna cat the file and it should display the content. Once we have verified that it is properly saved, we're gonna change the permissions. We're gonna use chmod and the umask, that is 400, 400, and the file name. So we change the permissions. And then you will SSH, that is SSH-I. Then in double quotes, you're gonna specify the path for your PEM. So right now it is on the same folder under the home folder. So I don't need to specify the entire path. I can just specify the file name, that is a g.pem, and then space the username, that is Ubuntu @ IP address of your private server.
Sir,
Yes.
I have clicked on the terminate instance, but it is still showing. I have refreshed the page 2-3 times.
It is gonna take some time. You can select the instance saves and you can also force terminate the instance. Again, you will see the option terminate with force. So it will
Oh.
force terminate all the instances.
Okay, sir.
Excuse me, sir.
Yeah.
Sir, actually, my credentials are not working, sir. I have dropped a mail to them, but the team is not still responding.
Which credentials are not working?
Like that,